This
Okay,
conference
so
will now be recorded.
I have worked with various other training institutes as well. Now I'm with Career IT. This is a brief introduction about my experience and training experience, guys, my work experience and training experience. Now, let me quickly give you the agenda of today's demo and we'll get started. So today's agenda, I'm going to walk you through what exactly big data is. Okay. And then I'm going to walk you through the data roles. So I just want you to understand what are the different roles that are there in big data projects, like who exactly is a data scientist, his roles and responsibilities, who exactly is a data engineer, his roles and responsibilities, and who exactly is a data analyst or a BI guy. Okay, and what exactly are his roles and responsibilities. I want you to understand. And now, uh, Spark, role of Spark in data engineering. And once we have this, you would have some good background setup, to understand our curriculum. I'm going to walk you through course structure and we'll wrap up this session with Q&A session. Okay. So before we jump on to demo, I would like to see what technology you are currently working on. Please use your chat window and ping me what technology you are working on. Just a single word answer to understand your background. Okay, Sairam SQL, Suresh Java full stack, SAP data management. Okay, cool. Let's get started. We'll try to make this session as interactive as possible. For you, there are a couple of ways to interact with me. One is you can either use your chat window or you can directly unmute yourself and you can talk to me. Okay. So before we jump onto big data, let's try to understand this term called data. What exactly is data, guys? What exactly you think is data? Any idea?
Data is like an information where we use to store or retrieve. Basically, it's like it's information.
Okay. So what is information?
It could be anything. It could be a personal data or financial data, or like where we can use for some analysis. Or like, yeah, it's basically okay.
Yeah, it makes sense. The only thing is we usually use this term information in a wrong context, because in our day-to-day life, whenever we want to refer to some details, we call that as information. Like, did you get sales information, or did you get information regarding that? Did you get information regarding this? But in our job context, information is completely different, guys. Let me explain. So data, I would say, collection of some attributes. Attributes could be some strings, attributes could be some numbers, attributes could be anything. Okay. So for example, you talk about employee data. So what do you store for an employee? Maybe employee ID and then employee name, employee. When I say employee name, it could be first name, last name, and then employee current location, employee role, employee salary, so on and so forth. You can store n number of attributes for that particular employee. And then you talk about sales data. Maybe you take any retail business, because I would be taking retail as most of the examples, guys, in most of the examples, because most of the users are pretty familiar with at least e-retail business. Okay, like because every one of us are used to Amazon or Flipkart or one or the other e-commerce websites. Okay, so when you talk about when you take e-retail business or e-commerce business, again you will have product data where you will have everything about a product, like a product ID and then product category, product price, so on and so forth, product image, and then for a customer to log in, we would be storing customer data. When we talk about customer data, we'll have customer user ID, customer password, and then customer saved addresses, customer preferences, whatnot. Okay, anything you can edit on customer portal or user portal, all those details would be stored in your database. Okay, and then you talk about sales data. Sales data will have what product has been sold, which customer have uh, bought that particular product, and then the actual price and then selling price, then quantity, and how much was sold, I mean for how much that particular order has been placed, so on and so forth. Okay, when you consider sales data, so likewise you take any data, it will have some attributes, guys. Okay, so sometimes data is referred to just numbers. Data are numbers. Okay, when I say numbers, like I said, we will have string attributes too, but the most useful data are numbers for business. Okay, and now what is information? Information is nothing but the useful data. Useful data is what we refer to as information. Okay, so boss, every data is useful. How could you say that useful data is information? Okay, then what is this useful data? Now, let's say I wanted to take some business decisions. I'm running an e-retail site or e-commerce site, and I wanted to take some business decision for the coming quarter. Okay, like I just want to understand how the sales has been in the previous couple of quarters, and then I also want to understand what are the most sold items in the previous year for the same quarter, and I also want to understand the customer preferences. So where can I get these details? I can get these details from the existing data in order to project what I'm gonna do for next quarter. Okay, so what I'll have to do is go back to my data and then uh, start analyzing answers for the questions I have asked. So how were my sales? Like I need to understand how much revenue has been generated in the previous quarters, which would be given by sum of sales. And then I wanted to understand what are the most sold items. I wanted to understand the most sold items in the same quarter previous year. All these things, this is what we refer to as information. So information is something which summarizes. When I say summarizes, it's not exactly summary, but it is something which would let you take a decision. Okay, let's say my revenue that has been generated in the previous 2 quarters is maybe some 50 million. Okay, so that would give me something. If someone gives me sales data, I will not be able to infer something. But if someone tells me that in previous 2 quarters the total revenue that has been generated is 50 million, then I would be assessing whether we are in profits or we are in losses based on the investment I have put in. Okay, so this is what we call as information. Like I said, information could be as simple as the total revenue. It could be as complex as lot of other business decision making parameters. Okay, now data, and we extract information from the data. We extract information from the data, and we extract information from the data. Our day-to-day activities would revolve around this process, guys. Extracting information from your data. Sometimes this information is also referred to as knowledge, and we call this process as knowledge discovery process. Okay, so our day-to-day activities would revolve around this process of extracting information from the data. Now Now, there are different roles here again. I mean, not a single person can do this process of extracting information from the data, but we have multiple roles there. One is data engineer, and the second one is data scientist, and the third one is BI analyst or data analyst or whatever. Let me put it as data analyst. Okay. So before we jump on to these roles, let's try to understand the definition of big data. Now you understood what is data and what is information, and now you understood the process of extracting information from data is something which is of paramount importance here. Okay, and that is something which we do in our day-to-day activities, right? Now let's try to understand what exactly is big data. Again, I mean, to talk about data, we have a lot of things to discuss, guys, like different types of data, structured, unstructured, and then we have transaction, historic, and then we have semi-structured data. I'm not getting into that classification in today's demo, as we have a limit of 1 hour. Okay, but I'm going to walk you through all those things during our regular sessions. Okay, but for now, let me try to give you a complete picture of what we do and how this course would help you to do those tasks. Okay, yeah, talking about big data, big data doesn't have any thresholds, guys. Okay, so maybe most of the people would define big data in terms of volume, but how much data is big data? Is 1 TB data big data, 500 TB big data, or 1 petabyte data big data? How much data is big data? Any guess? Any
Unlimited?
guesses around this?
Yeah, maybe
Unlimited, okay.
number of megabytes.
Mm-hmm. Okay, let me explain. So big data doesn't have any such thresholds, guys. Okay, so big data doesn't have any such thresholds. Big data is a relative term. Big data is a relative term. Let's say given infrastructure. When I talk about infrastructure, there are two things I would always refer to. One is storage, and the second one is compute. One is storage, and the second one is compute. When I talk about compute, I am interested in a couple of things again. Number of cores in your processor and memory. Again, when I say memory, I am talking about RAM. Okay. And whenever I'm talking about storage, I'm talking about hard disk, permanent storage, hard disk drive. Okay. So whenever I say something related to infrastructure, I'm always referring to storage and compute. Okay. Now, whenever you want to store some data or process some data, you need to have some infrastructure. Okay, so first things, in order to store that data, you need to have some hard disk, and then in order to process the data or in order to do some operations on top of the data, you should have compute. When I say compute, you should have some cores and memory. Now again, I'm never interested in what is the model of your processor. It could be Intel i3, Intel i5, i7, or any server processor or AMD Ryzen. I don't care. Okay, I'm always interested in how many cores your processors can offer, whether it is a quad core processor or octa core processor, hexa core processor, or 16 core or 32 core or 64 core. That is where I'm interested in, because the more the number of cores, the more parallel tasks you can do. As simple as that. Okay, so cores in your processor is something I'm interested in, and how much RAM your compute has. Okay, so that would define how much data you can process at a time, right? So now talking about big data, given an infrastructure, if a data cannot be processed or stored by that infrastructure, that data is big data to that particular machine. Okay, let me elaborate with an example. uh, Now maybe if I take a i3 processor, and maybe a 4 GB RAM, and let's say I want to play NFS Hot Pursuit. It's a game. It's a game. At the end of the day, in order to play that game, I'll have to process that file. Okay. So will I be able to process that file on i3 and 4 GB RAM? Definitely not. NFS Hot Pursuit is a game which would at least require 8 GB RAM with i5 processor to play it smoothly. Okay. And again, let's say I'm using the same configuration, 4 GB RAM and i3 processor. Will I be able to run a simple machine learning algorithm on 100 GB data? Definitely not. It will take eternal time and it will not be completed. So that 100 GB data is big data to a infrastructure with i3 processor and 4 GB. Okay. If you run the same 100 GB on a server, if you run the same 100 GB on a server with maybe 64 GB RAM and quad core processor, it would be pretty happy to process that data in like 30 minutes or 1 hour maximum. Okay, so the same 100 GB data is not a big data for a machine with quad core processor and 64 GB RAM. Okay, so that is what I have been explaining, guys. So big data is something relative, relative to the infrastructure you are using. If your infrastructure is not able to store or process your data, that data is called big data to that particular machine. Okay, so is it only in terms of storage? No. Or is it only in terms of processing? No, there are other parameters as well. Let me explain. We call them as characteristics of big data. One is volume for sure. When I say volume, the size of your data is so huge that your existing infrastructure might not be able to store it or process it. And second one is variety. Okay, types of data. So I haven't yet walked you through different types of data, but yes, to give you a simple classification, we have three types of data: structured, unstructured, and semi-structured data. Okay, and let's say you are using RDBMS to store and process your data. RDBMS tool, relational database management tool, it can only store structured data. You will not be able to process semi-structured or unstructured data using your RDBMS tool, okay, or RDBMS infrastructure. Okay, so because of this variety, if you are not able to store or process your data, yes, that is also big data to that particular machine. And then velocity. When you talk about velocity is something which is referring to the rate at which the data is getting generated. Rate at which data is getting generated. Especially velocity comes into picture when you are dealing with streaming data sources. Streaming data sources. Any idea, guys, what exactly is a streaming data source? One example. Let me explain what is streaming data, and then probably you can try to find out an example for streaming data. Streaming data is nothing but continuous generation of data, guys. Like your data would be generated maybe every second or every 5 seconds or every 10 seconds, depending on the frequency of your source. But yes, streaming data is continuous generation of data. That is the reason it's called streams of data. Any idea on streaming data sources?
Maybe a trading system,
Mm-hmm. Correct.
right?
Yeah, we
I
use
wouldn't
SAP.
I wouldn't say trading system, but
Yeah,
trading system I would say it has time series data. Though it is continuous generation, um, you know, it's a kind of an update rather than data generation. So I would refer that to time series data, not to streaming data.
Maybe a Facebook or like all these social media kind of thing.
Correct. Clickstream data, and then data that is getting generated from sensors. The best example for streaming data which is getting generated from sensors. It could be your IoT sensors, it could be any other sensors. They keep generating data every second, every 5 seconds, every 10 seconds, depending on the frequency which you configure. Okay. And then other examples could be web streaming data or clickstream data. Like one of our participants have suggested, clickstream data. So for example, be it any website, whenever you are clicking something in that website, you end up generating some data in the backend. Okay. I hope everyone are familiar with Google advertisements. Let's say maybe in Amazon.com or people from US, BestBuy.com. If you are searching for a particular product in that website, once you are done with your searching process, and whenever you are browsing some blogs, you would be seeing advertisements of the same product in those blogs. Okay. Okay, so that is usually done through Google Ads. Okay, and how Google was able to product, the data that has been generated in the backend after you made a click there, after you have made a click there. Okay, so that is what we call as clickstream data. For every click you make, we call them as activities. Not just Google, guys. Every website will have its own clickstream data. Say for example, even for our company, most of the users log into our portal and then do different activities. So to understand what users are doing on our website and on what elements they are interested in, to understand what elements they are interested in, we do capture their activities, which is through clickstream data. Okay, which is called as clickstream data. And then we do a lot of analysis. Let's say I'm running a e-commerce business again. Now, I wanted to understand US patterns. I mean, I want to understand the users search patterns, like what is the product most of the users are searching on. The best example is YouTube trending videos. YouTube trending videos. Let's say you have two to three different uh, videos. Like maybe one video could be trending at number one, though it has less number of views than the video which is having more number of views. Let's say video A and video B. Video A is having 5 million views and video B is having 20 million views. But still your video B could be at second place or third place because it's not trending. So the way they calculate this trending is how many searches are going in search box, YouTube search box. Okay. So again, that's an example for streaming data, or sorry, clickstream data. Same thing with Twitter as well. So Twitter also, you are seeing some trending hashtags. So whenever you have tweeted something with that particular hashtag, and whenever Twitter observes a surge in tweets using that hashtag, that hashtag would be in trending section, would be displayed in trending section. So these are the examples of clickstream data, guys. Trending might not be clickstream, but yes, YouTube definitely clickstream. Okay. YouTube videos and YouTube trending, YouTube views, they're all definitely clickstream. And then recommendations which you get. Okay, so whenever you have clicked for a particular product, the same product would be recommended, or product in that particular vicinity would be recommended. Maybe let's say you are looking for a vacuum cleaner. Maybe you are looking for a vacuum cleaner by LG in Flipkart. Maybe when you open Facebook or Instagram, and whenever you are going through the feeds, you will get a lot of recommendations on vacuum cleaners of different companies as well. Okay, it's all digital marketing, guys, and they all use this clickstream data. Okay. Now, yeah, like I said, whenever this kind of data comes into picture, it is something which comes under this velocity category, because you don't have any control on the rate of data generation. Let's say if a million users are using the same website at a time across the globe, you will see a surge in the incoming data. Like if 1 million users across the globe are uh, doing some activities on your website, you will get all the data at once to your system. And how you manage in your system internally is up to you. Okay, so this is something which comes under this velocity category. And finally we have something called as veracity. So veracity is referred to as data in doubt. Okay, so today we have abundance of data. we are spending a lot of amount on purchasing data. So how reliable that data is comes under this veracity. If you are not able to process or store your data because of any of these reasons, let's say I have a system which can process only structured data, so I'm not able to process unstructured data. It is big data for my infrastructure. Let's say I have some data, I'm not able to process that data because I don't know how authentic that data is. It comes under big data. And then let's say I'm dealing with clickstream data, or I'm dealing with data coming in from sensors, but I'm losing a lot of data because the latency between the sensor and my system is so high, comes under big data. And I have petabytes of data, my infrastructure is not able to handle it. Big data, as simple as that. Okay. For any reason, if you are not able to store or process your data, is called big data. So big data will have either one or more characteristics, more of these characteristics of these four. It could have volume and velocity, it could have volume and variety, it could have variety and velocity. Okay. So one or more, if your data is having one or more of these characteristics, it can be categorized as big data. Okay. So let me stop here. Any questions, guys? Any questions?
No.
Perfect. Now, in order to deal with this big data, Google have come up with something called as GFS, Google File Systems. Okay. Later on, it is taken by Yahoo, and they are the ones who came up with something called as Hadoop framework. So Hadoop is a framework, a distributed framework, I would say, which was invented in order to manage big data. Whenever I say manage, again, I'm talking in terms of two parameters. One is storage, and second one is compute. Okay. For storage, they have come up with something called as HDFS, Hadoop Distributed File System. And then for compute, they have come up with something called as MapReduce. Okay. MapReduce is gone nowadays. MapReduce and the related technologies. You might ask me, boss, you have mentioned only MapReduce here, but we have heard about other technologies like Hive, Pig, Drill. There is an unlimited stack, but all those technologies are built on top of MapReduce. When you talk about processing, there is only one single technology in Hadoop called MapReduce. Be it Hive, be it Impala, be it Peak, whatever technology you take, they run MapReduce in the backend, making your life easy as a programmer. Though you submit a SQL script in in the Hive, that SQL script would be converted into MapReduce jobs in the backend by the Hive framework. So I'm not mentioning other frameworks, but yes, only MapReduce. And now this MapReduce is replaced by Spark. Now this MapReduce is replaced by Spark. Okay. So before we jump on to what technologies we talk about in Spark, I wanted to introduce those roles to you. I want you to have some clear understanding on what a data engineer does, what a data scientist does, and what a business guy does. Okay. Now let's say I am owning a company abc.com. Okay, where I sell products, product A, B, C, D, E, F, some products I am selling on ABC platform. Okay, now that I have different ways to sell. I have a physical stores. I have physical stores located at different locations. Okay, I also sell my products on abc.com website, and then I also sell my products on Amazon. I also sell my products on Flipkart. Okay, and then I also do some marketing using Google Ads. Okay, and then I also does some marketing using social media advertisements like Facebook ads or Instagram ads. Okay, and um, maybe let's try to stop here. Okay, now let's say summer is coming up. and I wanted to give some offers to my users, to my customers, to increase the sale. Okay, to increase the sale, and also to uh, to encourage my customers to buy more products on my platform, kind of a promotion. Okay, now I cannot just give randomly products on, I mean offers on whatever product it is. Okay, now what I would do is I would call my data scientist. I would call my data scientist and I'll tell him, boss, I wanted to give some offers on the products which would create a win-win situation for our, for us retailers, and for customers as well. Data scientists should always have a business knowledge, guys. Okay, so even in the industry, whenever people are recruiting a data scientist, they would look for a guy with the same business knowledge. Okay, or at least the same domain. So for example, if your banking industry, banking and finance industry is looking for a data scientist, they would obviously be interested in a guy who have already experience working in the same industry. Similarly, insurance companies would look for a data scientist who have knowledge on insurance domain. Same thing applies for retail, same thing applies for technology, whatever. Okay, so data scientist industry would always expect some sort of business knowledge. Any finance companies or asset management companies would always look for a data scientist who has knowledge on that particular domain. When you ask me, is it mandatory? Definitely not, but preferably. But for a data scientist to work on a particular business problem, he should have business knowledge. Okay. Now I would call my data scientist. I'll tell him, boss, this is what I need, and you do whatever you want. Now let's say your data scientist would analyze the situation, and he wanted to run maybe A, B, and C machine learning algorithms. He have designed some machine learning algorithms, and for him to run this ABC machine learning algorithms, he would need data from multiple sources. Because let's say in our if you go to the different channels where I promote my products, I sell my products through physical stores, through my website, and then through third party websites, and then I have some marketing data from Google ads and Facebook and Insta ads. Okay, and then we have user activity data. So there are a lot of things there, right? Now, in order to run this algorithm, this particular guy, data scientist, would need the data to be combined and provided in a form of a single sheet where he can run algorithm. Okay. So basically, whenever you are attending a data science course, or whenever you are attending a, whenever you are, what you call, whenever you're practicing some data science problems online, they will be providing you with data sets. So in real time, data sets are not straightforward, guys. Data sets are not available in the format the way you see online. Okay, they have to be created, right? Now this data engineer would start his analysis. Now, data engineering steps. First step. Now, data could be present in multiple sources, like I said, maybe in a database of physical stores, and then database of abc.com, and then from Amazon and Flipkart, we literally have to purchase data. Here we can also purchase data of our competitors as well. Like abc.com, let's say xyz.com is also selling same product. Okay, I can actually pay Amazon and buy that particular data as well. Okay, they'll not be giving data at a low level, but at least you will get high level numbers. You would see how your competitors are doing in that particular space. Okay, so people would be buying it if they want to improve their business, because understanding the competitors business would always help you. Okay, so I'm purchasing some data from Amazon and Flipkart, and then I have my Google ads data, and I also have my Instagram and Facebook ads data. First things first, I have to get all that data into the environment I'm working on. That step is what we call as data ingestion. Data ingestion. So the process of getting data from the source to your environment on which you are working from is what we refer to as data ingestion. And next step, I will have to persist the data, whatever that is fetched from the source, data storage. And next, I will be applying all the transformations that are required in order to create data sets for my data scientist. That process is what we call as data wrangling. Data wrangling. And once I have data wrangling done, I'll have to store the transformed data into a table or a file or whatever it takes. Okay, so this process is what we refer to as extract, and then load, then transform, and finally again load, ELTL. Okay, in big data we follow this flow called ELTL. You might have heard about ETL when you have typical informatica or talent tools. You usually extract, transform, and then load. But when it comes to big data, it is always ELTL, ELT or ELTL, where you extract data and then store it somewhere, then you transform it and again store it somewhere. And once you are done with this process of ELTL, whatever the data that is available can be consumed. We often refer to that as data lake, can be consumed directly by a data scientist to run ML algorithm, or maybe by your data analyst to run AI and BI, sorry, to create any BI reports. Okay. Now let me explain what is this BI reports. So, like I have created data by doing whatever it takes, and then I have created this data lake from which my data scientist can consume data from to run machine learning algorithms. Simultaneously, my BI team can also consume the same data to create their dashboards. Okay, because if you remember, before we start discussing on this topic, I was talking about different questions, like how many sales has been, what is the total revenue generated in the previous 2 quarters, and then what are the most sold products in the previous quarters, and what are the most sold products in the current quarter previous year. Okay, so all these questions can be answered via the dashboard. Okay, so you have the data ready from which you can do this analysis, but you cannot provide that as a file or a text. Okay, it's always it is always appealing when you present the same results on a dashboard in a graphical format, formats like using pie charts, bar charts, and then pivot tables, whatnot. Okay, that would be more appealing for your business users. Okay, so that is when this BI comes into picture, business intelligence or BI reporting. So these are the guys who would be representing either the data directly from the delta lake, or it could be output from the machine learning algorithms, whatever it is, but they would be using these reporting tools and visually represent the output that has been generated, the final output that has been generated, which would be given to the business users for taking the business decisions. Okay, so this is the entire stack, guys. So our course is data engineering course. So here we would get to learn the different tools that would help us to do all these processes. So data ingestion, we would be talking about Azure Data Factory, because we are going to learn our course on Azure Data Factory, and you'll also get to learn about Spark JDBC. Okay, and then data storage, I'm gonna walk you through ADLS, and then data wrangling. Here we will learn about Spark, RDD programming, and then we'll also talk about Spark SQL. Okay, Second, data storage, it's going to be ADLS. And detailed course would be shared with you from one of our executives from Career IT. Okay. And then the programming language I'm gonna use to develop Spark applications, Python. Python would also be taught to you for a couple of weeks to give you basic understanding of the programming language if you're not coming from a typical programming background, right? And what else? Python, then Azure. We would be doing learning all these activities on Azure platform, cloud platform, and then the duration of this course is 2 months. Okay, and other details will be shared by career IT executives. Now, let me stop here to take your questions. Any
Okay.
questions, guys?
Yes, I
Yeah,
have Suresh. It's 2 months, right? Is it every daily classes or weekly classes? Like,
daily sessions. It's going to
oh,
be daily, and it would be taken in the morning, which would be your evening if you are joining from PST.
yes. Actually, evening what time?
That would be informed to
Okay,
you. Madan.
okay,
At
okay,
this
sure.
point in time, we don't have a concrete time yet. It could be from 6:30 to 7:30 IST or 7 to 8 a.m. IST.
Okay. Oh, no, 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 no
Okay.
problem.
Yeah, 6:30 to 7:30 or 7 to 8 a.m.
Okay, thank you.
Yeah.
Okay, here I have a question. Like, how do you deal with like a large files, like a clip, like a binary large objects? Does data engineering deal with the unstructured data?
Yes, it does. Might not be directly, but yes, we have to. When you talk about binary large objects, you are referring to some images, right?
Mm-hmm. Mm.
So let me tell you what. ADLS itself is a blob storage.
Okay, okay,
Okay. So whatever you are storing in ADLS, it will be storing as a blob, and it can internally deal with whatever you want. I mean, talking about processing your multimedia data like images or videos or whatever. So generally, we don't cover that in our course, but usually we have the image processing algorithms which will do that for you.
okay,
Okay, you don't have tools directly available, but yes, you have open source algorithms which you can leverage in order to process that data.
okay.
Most of the time we end up dealing with either structured or semi-structured data. When I say structured, whenever you are pulling data directly from your warehouses or any tool which exposes JDBC connection, be it
Mm.
Amazon Redshift or be it Azure Synapse or be it Google BigQuery or be it your Oracle Exact Target or SQL Server or whatever, any database, any data warehouse which is exposing JDBC connection, you can pull that data, which I always refer to as structured, and then you talk about CSV files or JSON files. You talk about Parquet files, or sometimes you got to pull data by calling some REST APIs. So all these things would fall under semi-structured data. Okay, so I would say 99% of the time we would be either dealing with structured or semi-structured data.
Got
Okay,
it.
so I have experience dealing with unstructured data as well, especially when I'm working for this domain called fraud investigation. So
Mm-hmm.
basically, there we have dealt with the email data, which is completely unstructured.
Okay.
Okay, so there we have implemented an algorithm using MapReduce. It was in 2015.
Mm-hmm. Okay.
Okay, but you
Yeah.
don't have a direct tool to query or to automate your process for dealing with unstructured data. But at least you can store that as a file on HDFS or ADLS or whatever storage you are using, and you can write your algorithms. I would say use case specific algorithms to handle that unstructured data.
Okay. Okay.
One
Got it.
advantage you could get here is the processing would happen in a distributed manner, parallelly.
Okay. Okay. Okay, thank you, Suresh.
No worries, Madan. Any other questions, guys?
Uh, hey, one question. Are you
Yes,
going to
please.
cover any real-time project example, something like that? Any real-time, like in a small project to understand, like end to end?
Let me tell you. It's a good question, project related.
Yeah.
So basically, whatever the examples I'm gonna tell you, they are real-time examples. You might not be working on a real-time data set, but use cases are real-time use cases. Say for example, I'm explaining a concept of a user-defined function while we are dealing with Spark SQL. So maybe the data set could be only in MBs, or maybe sometimes it would be in KBs itself.
Mhm.
Okay, but the use case is real-time use case. So for example, I would be teaching you the company name matching algorithm, I mean company name matching use case, where we use something called as Levenstein distance.
Mhm.
Okay, we implement some code to implement Levenstein distance in Python, and we register that as a UDF, and we run it on a small data set because we don't have data sets on scale for our training. But the use case is genuine. That particular use case I have used in like 3 projects. When I'm working for Google, when I'm working for my current company, when I'm working for Deloitte, I have used that particular algorithm, Levenstein algorithm, because most
Wow.
of the time, whenever I'm combining 2 datasets, let's talk about the same example. Maybe I have got some sales information from Flipkart of my competitors, and also from Amazon. Okay. Now
Yeah,
Flipkart will
got it.
have its own ID. Amazon will have its own internal ID. So in order to understand whether it's the same company or not, you need to do the name mapping.
Okay,
Okay.
got it. Thanks.
Maybe
Yep.
in Flipkart it could be ABC only, but in Amazon it could be ABC Private Limited, or whatever. It could be of different names. So
Okay.
we implement this Levenstein distance to map these two string matching, these two strings.
Yeah, got it. And one more thing is like here you said you are covering a Python. So
Mhm.
is it uh, available with only Python, or can we cover Java or anything
We will
other
not
than
be
Python?
covering Java and Scala.
Okay.
So basically, Spark can be implemented in 3 different languages. I would say 4:
Mhm.
uh, Java, Scala, Python, and R.
Oh, okay. Okay.
Okay,
Got it.
R is
Mhm.
completely for data scientists, so I'm ruling that out.
Mhm.
Java is never used. Java is used, decades ago, but not now.
Okay.
At least on Spark context.
Mhm.
Okay,
Okay.
so
Got it.
the
Yeah. Got it.
only 2 competitors are Python and Scala. And
Mhm.
I would say next couple of years it's going to be only Python, because already PySpark have dominated Scala like anything in the past couple of years.
Okay.
Okay,
Got it.
earlier there
Thanks.
was no option of Python. That is
Yeah.
the reason people used to look at Scala, because Java is not a viable option. But now with the introduction of Python, Python has taken over a lot of projects over Scala.
Mhm. Yeah. Thank you.
Yep. Any other questions, guys?
And what about the software? Like in these 2 months, all this to practice anything, right? Do you give any remote systems to practice, or
I will give you a couple of options. One is either you can go with the same infrastructure which I'm gonna use,
okay,
Azure and Databricks. We have something called as Databricks. Okay,
okay,
so everything is going to be cloud. Okay,
okay,
so Azure offers a free subscription for 1 month.
okay.
Okay, definitely that's not going to be sufficient because you wanted to practice this definitely more than 1 month.
Mm-hmm.
Okay, so Databricks as a cloud tool offers you uh, free subscription forever. Okay, they
Okay.
would be giving you some 15 GB RAM and 2 cores, which is pretty much sufficient. But the only thing is you will not be running it on Azure.
Okay.
But like I said, Databricks platform is present in Azure, in AWS, in GCP as well, Google Cloud.
Okay.
There would be minor differences while you are porting code from different one cloud to other cloud. I will be explaining that, but for your practice, if you want to pay and use, you can have a subscribed account for Microsoft Azure, which would hardly cost you 5,000 bucks, 5,000 INR. Okay,
Mhm.
per month. If you don't want to waste that 5,000 INR, because when there is an alternate, there is no point in wasting the same amount. You can use a Databricks Community Edition to practice.
Okay, sure.
Okay.
And with this course, which certification can we aim?
I would say with this course, you would cover 50% of Azure data engineer certification.
Okay,
DP202 is the code.
okay,
Okay. In addition to this, you might have to learn Azure Synapse, and there are a couple of other tools for that certification. So I would say 60% of the Azure Data Engineer certification topics would be covered here.
okay, okay.
Cool. Thank you guys. Thank you so much for your time and attending our demo. Just a small request. Please leave a feedback in the chat window before you leave. Maybe a one-liner feedback. How you felt about today's demo?
Sure. Thank you.
Thank you, everyone.
Thank you.